going to talk about how do you transform your ES5 code to ES6. Interesting, right? Cool. Let's get started. So what is ECMAScript 2015 or ES6? So ECMAScript 2015 or ES6 adds a set of new features to ECMA 262 standards. That's adding a new set of features to your existing JavaScript. Okay. In order to look at what are the features provided by ES6, you could go ahead and visit GangaX. It's a compatibility table. It provides you what are the features provided by ES6 and where is it supported and which browsers or which engine. Okay, so I'll not be going through this. I'll get moving, right? So what is the adoption rate in Node.js, by the way? In Node 4, there were close to 50% of the features which are supported, and Node 5 had close to 60%, and Node 6 and Node 7 has more than 90% except proper tailgate. Okay, so let's move on. So let's discuss the first topic for today. What is function defaults? So default function parameters allow formal parameters to be initialized with default values if no value or undefined is passed. Okay, so how was this done in ES5, or how was this problem solved in ES5? Let's look at that problem. Okay, so you're trying to add two numbers. Okay, it's a very simple function. If you're looking at this code, it says x or 0. If you don't have an x is undefined, I'm going to plug 0. If it's y is undefined, I'm going to assign the value to 0, right? So in that case, add 2 comma 3 is going to return 5, add 2 is going to return 2, right? That's very simple. So how is this done in ES6? Okay, so this is what function default provides. You could say x is equal to 0, y is equal to 0, rather going ahead and doing this way where you say x are 0, y are 0. I think this looks more simpler with ES6. Okay, this looks like a syntactic sugar, but certainly this adds more value. You could also go ahead and say say that x is equal to 0, and you could say y is equal to x. In that case, it is going to assign y value to the, in this example, let's say add 2. What this is going to do is 2 is going to, it's going to return 4 because x value is 2, and that is going to get assigned to y. Okay, and this is so cool that you could do a lot of things. Okay, so let's move on to the next topic for today. Okay, so REST parameters. What is a REST parameter? I think I've been in love with REST and spread for quite a while now. So a REST parameter is a syntax which allows us to represent indefinite number of arguments as an array. Okay, let's look at how was this solved in ES5. Okay, let's take an example of a simple function called logger, and what you're trying to solve is logger comprises of 3 parameters. If you look at here, the first is the type, where you're going to pass the type of the argument is error, and the second is what is the error type? Its severity is high, it's an object, and it has a next a message associated with it. Okay, similarly the third parameter is severity and message. What you would have done here is, what I've done in this function is, I'm going to type var type is equal to arguments of 0. Okay, in JavaScript you could access arguments directly using the arguments okay, and arguments of 0 is going to assign the type, that is error, and I'm going to just create a message as an array. Okay, I'm going to push the messages into a stack of array, and I'm going to return type plus messages. So that is going to return error, cannot read property, and product is defined. This might look, what is this guy done with messages? So if you try to concatenate a string and a message, you're going to get comma separated string out of the box from array. Okay, so this is how in ES5, and let's try to tackle this in ES6. That is what REST comes into picture. Okay, so what we had done is whatever the arguments is going to be remain same. Rather, using arguments, what I've gone ahead and said is, I'm going to say the first argument is going to be type, that is param is going to be of type, and the second is a REST operator. So what is this going to do is, it's going to plug all the items over here, that is these two items, and I'm going to push and assign it to locks. This is way simpler than what we did here. Rather going ahead and pushing into a messages array, this is going to assign all these things into locks. Okay, and what happens now is you could just go ahead and do the same thing. Okay, rather saying, you could say messages is equal to array, and you could start accessing logs of I and message. This looks way simpler than what we had done here. So we don't know what is happening, we don't have any arguments passed. We try to plug the argument and assume that that's how it works. Okay, This code looks much simpler, and this is how REST works. REST is going to plug all these guys together and make sure that it is combined together to form an array here. Okay, that's cool. That is what REST talks about, and let's move on to the next topic. The next topic is spread operator. What is spread? A spread is a syntax which allows an expression to be expanded by comma separated values. Or it's the same, but it's going to, what I would say is it's an exact opposite of REST. Okay, so you're going to get comma separated values. And let's take the same example of logger. Okay, in ES5, what we would have done, the function still remains the same, and rather what I've done here is I'm going to just pass it as an array. So the last time across I passed arguments. Okay, the first was an object, the second was an object, whereas now I felt I have to refactor, and I've gone ahead and added errors as an array. Okay, that sounds good. And in ES6, what you would have, ES5, what you would have done, right? So this may look complicated, but it's simple. Okay, so what I've done here is I've called the logger method. Okay, and I've called apply. I'm going to pass a context as an object. Okay, so it's an empty object because I'm not passing anything specific. It's an empty object as a context. And what I have gone ahead and done is error. Error is a string. Error is a string, array of string. Okay, and I've gone ahead and concatenated errors. Okay, so this is the arguments. It's an array of arguments what I've passed, and this goes ahead and sits down in the logger, and it's the same thing applies. I'm gone ahead and done the arguments of 0. This is how you would have done in ES5. Okay, so how simple it is in ES6. Okay, I still have the errors as an array of errors. Okay, and what I have done here is it's exact opposite. If you look, this is what a REST syntax looks like, and errors is a spread syntax, which is going to spread these values to comma separated values. Okay, so what it does is it goes ahead and says it's going to take this guy as a single argument and this guy as a single argument, and it's going to take this value back to logs. Okay, logs, what it is going to assume is, oh, I've got a comma separated values, I'm going to just go and combine these guys together, right? So this is how it works. And REST and spread are exactly opposite to each other. REST means I'm going to combine, and spread means I'm going to spread these values into comma separated values. Okay, that's simple. So let's move on to the next topic. Okay, next is object literals. Okay, an object literal is a list of 0 or more pairs of property and names and associated values of an object enclosed in curly braces. Okay, so how was this before object literals? How was this done in ES5? Okay, so in ES5, let's take an example of very simple function, a method called region service. Okay, region service has a nested function called get region. Okay, and get all regions. Sorry. Okay, so I have a method called get region and get all regions as a nested function. And I think better let me open up the code editor. So we were looking into object literals, and let's see ES5. Okay, so I was talking about region service, and we have get region and get all region as a nested function. Okay, and what get region is going to return is going to return a single region, and get all region assumed to be written or assumed to be returning all the regions. And in this case, if the get region service has to return all these methods, what you would have gone ahead and done is have gone ahead and said, hey, get region and get region again, get all region again, because you're publicly going to expose these APIs. And in case I'm going to say, hey, I'm going to get random region, I'm going to write this function out here, right? So this is how it looks in ES5. And if you go ahead and execute this function, you're going to get that output out. Okay, so how is this done in ES6? Okay, so in object literals, it's going to make your life more easier. Okay, the same piece of code what we had written in ES5, and we are trying to expose the API, that is we get region colon get region. It becomes just get region because the name is same. You don't have to repeatedly go and say that get region colon get region. Now you could just go ahead and say get region, get all regions, and rather saying get random region as a function. So supposedly if you looked at the previous code, it was saying get random region as a function. You could go ahead and just write a shortcut syntax here. Okay, get random region, just say it's a function and just return that value. This is way simpler than what we used to do in ES5, right? So this is what I believe is this syntax sugar looks way simpler and more readable compared to what we used to do in ES5. Okay, let's move on to the next topic for now. Okay, I think we tackled this. Let's go on to the next interesting topic, that's template literals. What is template literals? Template literals are string literals allowing embedded expressions. I think it brings a lot of good. I think this is one of the exciting feature what I have been looking out for JavaScript for quite a while now, and it's part of JavaScript. And I was using handlebar and a lot of templating library to solve this problem. Okay, so how does it work, and how was ES5 code looking? Okay, so let's take an example. Get lucky number as a function, and you want to return a lucky number that's going to return between 0 to 9. Okay, and what you would have done and ended up doing is you say have a string called your lucky number. You would have gone ahead and concatenated with the lucky number, and you would say, hey, your lucky number is so and so. What is a random number being generated, right? So how you could this code could be made simpler with ES6. So you go ahead and say have backtick. So no more single quote or double quote. You're going to use backtick across your source code. Okay. So you're going to say your lucky number is, and your variable is going to be defined this way: dollar curly brace, and that's your variable. That's way simpler and looks more cleaner. And this is how template literal looks. Okay. And this is way simpler than what we used to do in ES5. Okay, let's move on to the next topic, that's destructuring. So what is destructuring? Destructuring is an assignment syntax, is a JavaScript expression that makes it possible to extract data from arrays or objects into distinct variables. Destructuring may be confusing initially, but it's a very powerful feature, okay? And you just closely look at how we would have done in ES5, okay? So let me move on to destructuring in ES5 before. Okay, let's take an example of a simple calc function which is going to return add and subtract method. Okay, so what you would have ended up doing here is you say I'm going to say add is a variable which is going to hold add function, and I'm going to say add 4 comma 5, and that's going to return 9. And this is how you would have done it in ES5. Okay, and let's assume you have operators as an array. Okay, you're going to have plus and minus, and you want to pluck the add operator out of this. What you would have ended up doing is add operator 0, right? That's how I would have gone ahead and done, right? So how does this work in ES6? In ES6, what we could go ahead and do is we could break this guy calc and say that, hey, I'm going to plug this guy add out of this. Okay, it's an object. I'm going to say, hey, go ahead and pluck add out of this guy. Okay, so I'm just going to say add, and you could also go ahead and pluck sub, and add is a variable which could be still assigned add 4 comma 5, and you could also go ahead and say sub, and sub is 5 comma 4, and that's going to return you 1, right? So this is how it looks. This looks way simpler than what we used to do in ES5, right? So I don't want to go ahead and say calc, then go ahead and pluck add out of it. This is how ES6 looks. Okay, this is an object destructuring. Let's look at the same example for an array destructuring. Okay, so we could go ahead and destructure an array as well. I can go ahead and assign add operator, okay, and sub operator as a variable back to these array item. Okay, so now if I pluck add operator, this is going to return me plus, right? This is way simpler than what we did the last time across. I think we've been using destructuring quite a while now. I think if you've been using import statement, right? Let's take a very simple example of an import statement. What you would end up doing is import add from calc, right? So this is how you would have done, or you are still doing it. This is how destructuring works, and import is a major feature where people try to export and import and value using the destructuring is more popular in that aspect. Okay, so I believe you got an understanding of how destructuring works. That's more the next part, that's block scope. Okay, no more syntax sugar or syntactic sugar. We'll more talk on how functionality more into functionality, I would say. Okay, so block scope. Constant let introduces block scoping in JavaScript. Before this, there was no concept of block scoping in JavaScript. And let's take an example of before block scope, what all problems you would have ended up and how you would have resolved that problem. Okay, I think let's move to the ID, plug this guy out, scope, and ES5. Okay, let's take a very simple example. Okay, for pi is a constant. You would have gone ahead and assigned 3.14. Global is 10, and global, you've just gone ahead and called the function called global. I believe there's a mistake here. Oh, no, perfect. That's perfect. So this guy is not required. Gone ahead. Okay, global is 10, so it's true, and now it's going to assign bar global is 100. So what you're expecting here is global into pi. Okay, global into pi is 3.14 into 100, that is 314, right? So you ended up having 314, even though you assumed that the var was within this block. It's gone ahead and leaked out. Okay, and you've got 314. This is how you would have ended up in JavaScript. If you've been doing it for quite a while, this is what you would have got a problem, right? You didn't realize that the variable was redeclared here, right? So let's move on to the next important problem which you've been facing, right? Let's assume a very simple scenario. You're trying to iterate over 10 values, okay? And for loop is, you're going to iterate over for loop, and you're going to set a timeout, okay? And in set timeout, you're going to log out these values, and after a second, and you would end up realizing that each and every time the set timeout is going to print, it's going to print 10 times, right? You're expecting the value to be 0, 1, 2, 3, but it ends up printing 0, 10 times. The reason is it remembers the last state. The last state, what it remembers is 10, and it just goes ahead and prints 10. This may seems confusing, and people would go ahead and write a closure function here to resolve that. Okay, and that's way confusing, and most of them get confused when we talk about closure, right? So how does it work on ES6 now? I don't have to keep var pi, which is going to be replaced with a constant, and constant value cannot be modified. That's way good. Okay, and now if we say let global is equal to 10, I'm going to say global, and let global is equal to 100, and what you end up getting is not 100 anymore. You end up getting value is 10. This is awesome. So let doesn't leak the value out of this block, so it only holds to this block, and the answer would be 10 still. So this is what let provides. So this is way helpful than what you would have ended up doing in var. Okay, and let's take an example of for loop. So I said the same example where if you would have used var, you would have ended up getting the last instance of I, what it remembered, that is 10. In let, you don't have to tackle this anymore. You end up getting 0, 1, 2, 3, and no more you have to worry about the closure problem, which is a classic problem in JavaScript, and this is way tackled out of the box for you, right? So I think these two example is very much sufficient for now. Let's move on to the next topic. So next topic what I'm going to talk about is arrow functions. Okay, what I would say arrow function is similar to lambda, or in CoffeeScript this has been a fat arrow function was existing, and ES6 everyone felt this was a good feature which was existing, and they plugged this feature out, and it's really very simple to do. Okay, what is an arrow function, by the way? An arrow function expression has a shorter syntax compared to a function expression, and does not bind its own this argument super or new dot target. Arrow function are always anonymous, so it's still a function, but it's an anonymous function. These function expressions are best suited for non-method function, and they cannot be used as a constructor method. So don't try to use this as a constructor method like I'm going to write a constructor method called person. Don't try to do that. So these are not suited for that. These are very much specific to be a anonymous function or a shortcut or a shorthand functions for you to do something. Okay, and the next thing you have to be very careful is the context, or it scopes in a lexical binding of this. No more your this context. This context more refers to your function itself. not to what it is coming from. Okay, this might sound weird, but you cannot use call or bind or any apply to arrow functions. Okay, so let's look at an example of ES5. How does a simple function look like, by the way? So a simple function would something look like add. Add is a function. I'm going to say return a plus b, and sub is a function which is going to return a minus b. Okay, the value is going to be, if you're going to say add 2 comma 3, it's going to return 5, and sub is going to return 5 comma 3. And this is a very simple function. And how do you translate or transform this to ES6? And in ES6, this is what an arrow function. Arrow is something like a equal to and then a greater than symbol. Okay, and what you do here is input results in an output. So this is how you could look. This is an input what you pass, that's your arguments, and you return as an output. What you have done here is your input, and you just put an arrow here, and that's your output. And if the output is just a single line, you don't have to go ahead and say that I have to do this, what we have done, this curly braces, right? You don't have to do this. You could just go ahead and return the value directly. That's a very simpler way of doing it, and I believe this reduces a lot of code. Okay, and let's move on to the next thing. That's a constructor binding. Okay, so let's take a very simple example. I've written a function or a constructor method called greeting. This is the way you would have done it in ES5. Okay, this is not arrow functions. Okay, so greeting is a constructor method. Okay, you end up saying var self is equal to this. The reason why I'm doing this is you have this dot say hello. You're going to say hello. Okay, when you call, you create an instance of your greeting method, and you're going to pass the value as John. And if you say g dot say hello, it's going to say hello John. Okay, and let's write an asynchronous method called say hello async. Okay, in this case you're going to say a set timeout function, or this is going to do an asynchronous call behind the scene. Okay, and what you go end up do what I'm going to end up doing is after a second I'm going to print hello self dot name. The reason self is, if you go ahead and do this dot name, this might refer to the node processor, or if you're in a browser, it's going to hook the context back to your window or the previous function. Okay, so that's the reason you go ahead and say that, hey, var self is equal to this, or that is equal to this, and you're going to refer self dot name. And this is how you would have got the context or the value. But if you're going to tackle with constructor in ES6, that is through arrow functions, the scope is lexical binding. That is going to refer to your parent function directly. Okay, the same example we've just translated to ES6 syntax. Okay, and say hello is going to be a very simple arrow function, which is going to return hello this dot name. This is your template return which we discussed earlier, and it's going to return this dot name, that is your value. And we're going to say, hey, hello John, and let's say hello sync, and I've gone ahead and translated everything to arrow function. It's not necessary to translate everything back to arrow function, but you need to know when to use an arrow function and when not to use an arrow function. Okay, functions are still helpful, but I would go ahead and prefer functions wherever it's applicable. And if I feel arrow function makes more sense, sometimes I go ahead and add arrow functions. Okay, so let's say set timeout. Set timeout is, it's a function. It's going to return you back the value. Now I've gone ahead and said this dot name. Okay, with arrow function, what it goes ahead and does is it's going to hook the lexical binding. Okay, the scope is going to be hooked to the say hello sync, and that this refers to the constructor method, and you say this dot name still refers to the name what was passed. So you don't have to go ahead and do this var self is equal to this, or that is equal to this, and reassign the value, right? So that's no more required in your arrow functions. The context is very much bound to the lexical part. Okay, let's move on to the next important topic, classes. I think been people have been asking why the heck we do have constructor functions in JavaScript, and your function becomes your first class objects, right? In JavaScript, in ES5, right? Classes has been existing in other programming languages like C#, Java, way longer, and even in Objective-C, right? So, but JavaScript never intended to use classes, but the need for classes have come, and I think more and more people coming into JavaScript, classes was more required to be added into the new set of features, so people more get used to JavaScript and start learning JavaScript in a quicker way. Okay, under the hood they still use the prototypical inheritance, so gotcha, that's still used, right? So what are JavaScript classes? Is in ECMAScript's JavaScript classes introduced in ECMAScript 6 are just a syntactic sugar over JavaScript existing prototype based inheritance. Okay, they still use under the hood prototype based inheritance. The class syntax is not introducing a new object oriented inheritance model to JavaScript. JavaScript classes provide much simpler and clearer syntax to create objects and deal with inheritance. Okay, so before this, how you would have done it in ES5? Let's look a very classic example. Maybe let me move on to the editor. Okay, ES5.js. Perfect. So let's assume you had a constructor method called person. Okay, person has two properties called this.name and this.age, and I have a say hello as a method. You hook it to a prototype chain. The reason you hook into the prototype chain is that it doesn't get defined whenever you create an instance. Okay, that's the reason it's hooked into the prototype chain, and you end up getting better performance. And this is how you've been doing in JavaScript in ES5 or the older way. Okay, and when I say new person, I create an instance of the person John, 25. I can say person1 dot say hello, and this is going to return hello John. Okay, and in case if I want to extend this person for something called as employee, and employee extends the person, now this becomes more tricky in JavaScript. Okay, this is where prototypical inheritance comes into picture. Okay, in classical JS, this is what you would have done. Let's assume employee is still a constructor method which has name and salary. Okay, this dot name is equal to name, this dot salary is equal to salary. Okay, and what you would have done, the first line here is employee dot prototype is going to chain to the new person, so it's going to chain all the uh, methods or the properties of new person. Okay, here's where the inheritance occurs. Okay, next is you're going to also going to do is you're going to assign the constructor method back to the employee. Okay, you're going to assign the employee method back to its constructor method, and otherwise the constructor method is going to point to the person constructor because you have gone ahead and hooked this guy here. All right, and the next thing is if you had to do something like a super. Okay, super, if you had to do something like a super, what we do in JavaScript, you end up doing is you say employee prototype dot parent. I'm going to create a new object or called as parent. I'm going to hook this guy back to person dot prototype. Okay, and when I want to say, let's say hello, say hello has to return hey Smith. I've passed the value called Smith and 2000 as a salary. If I say employee one dot say hello, it's going to say this dot parent. Now what is the parent refers to is the super. Okay, and going to call this guy, let's say hello, and now it's going to say hello Smith, and this is going to print something like hello Smith, and then your this thing. Okay, your exclamations. So this is what you're going to get the value out. Maybe this looks way complicated what we used to do in JavaScript in ES5 way. So how is this simplified using classes? ES6. Okay, so let's move on to the more class-based approach. You have a person. Okay, person is now the class. It has a constructor method where you can go ahead and initialize. This still refers to the context. This dot name is equal to name, and this dot age is equal to age. And this is your methods, what you define. Say hello, this dot name. This looks more simpler and more resemble the resemblance to the old classical way of doing in other languages, right? And what you have to do in case if you want to extend the person, you could just go ahead and say now employee extends person, and your super, the constructor method can just inherit super. So this is very required in JavaScript. Okay, and this dot name and this dot salary. Okay, and now if I go ahead and say that super dot say hello, it's going to print the same hello myth, right? So this looks more simpler and more readable, and I think this is way simpler and more readable for anyone who is starting up in JavaScript. Maybe I'm very much fond of doing ES5 way, but I feel this is more simpler for anyone to read and get an understanding of how inheritance works. All right, let's see the next topic. The next topic, what I thought I would start covering up is generators. Okay, generators are functions that can be paused and resumed. there was no concept of pausing and resuming in any function in JavaScript, right? So where does this help? This helps with many applications like iterators, asynchronous programming, etc. Okay, so let's look at a very classic. This may not be resembling what we are trying to tackle, but I've just taken a very simple use case or an example. So let's assume you have a method called get payment. This is ES5 way to be precise. Okay, in ES5, what you would have done is get payment history. Okay, get payment history is going to return the history of payment, and which is hooked to a nested method called fetch history, maybe a method which is I've inherited from somewhere, and it's going to fetch the history back and return you the value. Okay, and in between I do have a validate function. Okay, validate function is what it is going to do is it's going to validate before fetching the payment history, right? I want to check if the user is valid or not. If the token is valid, then I'm going to fetch the return the history of the payment. Okay, so in this case, what we would have done is we would have gone ahead and called the validate method. Okay, I would have passed the token. I would have checked if the user is valid. If the user is valid, then I'm going to get the history and return the history back to the user, right? This is how you would have done it in JavaScript and in ES5 way. And in ES6, how does this work? Or I've just made this work using generators. This may not be the right use case, but you might get an hang of how generators work with this. And generator functions, you have to use a star. So it just your function proceeded with star is a generator function. This is how your generator function is resembled. And what I've gone ahead and done is I've gone ahead and hooked the validate method here, and the fetch history retains here. So what I've done here is the first step is I've gone ahead and called the payment history method. The iterator first goes ahead and calls the payment history method with the token. Okay, the token comes back here, and the what it is going to do is it's going to yield. So it is based out of yield. Okay, and yield is going to go ahead and say, hey, validate and return the validate and pass the token to this guy. Okay, so what it does is it passes the token and does the validation. And when I do a validation, I'm going to say is valid iterator.next. Now the function is paused. If you understand, this is where the function is getting paused. You don't have to have multiple functions. The function got paused at this point of time, and now I say is valid, and I'm just going to say iterator.next. So what it does is it's going to check, hey, is this guy the valid entry or not? If the entry is valid, that is the if it is validated, then it's going to if is it valid dot value is going to be true, then I'm going to iterate the next time across. Okay, and if I say history is equal to iterator dot next, I'm going to pass a year. Year is nothing but where did I get the value year? Year is this. I pass the year now here, and when it goes back, it takes a year and gets the value back and returns the history. Okay, maybe a bit complicated, but if you observe very carefully again, I do get payment history is the method. Get payment history method takes the token, and it goes in here and yields this, that is your token. And if your yield is going to return a true, then you get the value back, and you're going to return iterator.next, which is going to hold the history and return the value. That's it. And you could do it for multiple iterations, and you could just stop and pause the function at any point of time. Cool. So this is how generators work, and in case if you want to follow along this tutorial or the session, you could just go ahead and visit github.com Ajinway ES5 to ES6. Hope you guys like this. Just go ahead and look at the code to understand much better. Thanks. Have a great day.